Good day, everybody. The topic we shall discuss is network model. Under this topic, we shall consider the meaning and definition of network model. We shall consider the rules guiding network model. We shall consider how to construct the performance evaluation and review technique diagram. We shall consider how to do the forward pass. We shall consider how to do the backward pass. We shall consider how to determine the duration of the project. We shall consider how to determine the critical path. We shall consider how to determine the earliest start time, the latest start time, the earliest finish time, the latest finish time, and the slack. And of course, we shall also consider how to what is called project crash. A network diagram is a diagram that shows the set of activities that must be performed in the execution of a project. Each activity is represented by an arrow. Each activity is represented by an arrow to indicate that the activity is still ongoing. Once the activity is completed, a circle is drawn at the edge of the arrow, which represents the circle, also called an event or a node, which indicates the completion of the activity. In constructing the network model diagram, first of all, there are steps that must be followed. The first step is to be able to identify the activity, all the activities that will be involved. All the interrelated activities must be identified. They must not only be identified, their duration, the number of time or the duration it will take to execute each activity must be clearly stated. So the first step is to identify the activities and their duration. Step number 2 is to identify the preceding activities. Step number 2 is to identify the preceding activity for each successive activity, meaning that we in a network model, we have what we call preceding activity and we have what we call succeeding activity. The preceding activity is the one that comes first, while the succeeding activity is the one that commences at the completion of the preceding activity. The third step is to then model this activity into a network. Model the activities into a network diagram. In modeling these activities into a network diagram, there are some rules that must be observed. There are some very, very important rules that must be observed. These rules must not be violated, otherwise there will be a problem in the modeling of these activities into a network. The first rule that must be observed is that there must be only one starting point and only one finish point. There must be only one starting point and only one finish point. The second rule that must be observed is that there must a preceding activity. The second rule is that a preceding activity must end before a succeeding activity can commence, meaning that an activity cannot commence except the preceding activity has finished. For instance, if activity C is a preceding activity to activity G. This simply means that activity G cannot commence until activity C has concluded its own task. The third rule is that two activities cannot originate from the same source and end in the same destination. The third rule is that two activities cannot commence from the same source and end in the same destination. Two activities cannot start in the same place and head to go and finish in the same place. The fourth rule is that there must be an outlier. There must not be an outlier. No activity. There must not be a standalone activity. There must not be an outlier. Simply means that there must not be a standalone activity. All activities must be interrelated. They must be connected in the network diagram. Having considered the rules that must be observed in the construction of the network model, let us now consider this example where this column represents the activities which are the tasks that must be performed for the projects to be completed, while this column represents the preceding activity. And of course, one of the rules that we have considered is that if a preceding activity does not conclude, a successive activity cannot commence. While this colon represents the duration in weeks of the activity. We shall now use this information to draw what is called the performance, evaluation, and review technique diagram. Of course, in drawing this diagram, I shall be guided strictly by those rules that have been established. The first rule is that there must be only one starting point and one finish point. There must be only one starting point and one finish point. Each of these the starting point and the finish point must be represented by a load or an event, which, as we explained before, means the completion of a task. But in this case, this is the commencement, this represents the commencement of the task, and this represents the completion of the task. Now, all the activities will then be inputted into this diagram using axe or arrow to show direction. But one thing is very important: while drawing the arrows that shows direction of these activities, we must be able to identify the direction where each activity commences from and where each activity will end. Where each activity commences from and where each activity will end. Now, for me to commence, I will draw the first activity, which is activity A. But before I draw the activity A, I need to know the origin of activity A and where activity A will conclude. In the example, I see that activity A does not have a preceding activity. Activity A does not have a preceding activity because in the column of the preceding activity, what I find there, opposite activity A, is a dash. That same column then, having seen that activity A does not have a preceding activity, it simply indicates or it simply implies that activity A will start from this origin. If you look again, you will see that activity A is under, I can still find activity A under the preceding activity. I can still find activity A standing alone under the preceding activity. It is standing alone facing activity E. As it is standing alone facing activity E, it means that activity A is not ending with anybody. So I can draw activity A from the source and end it with this circle. The same thing with activity B, does not have a preceding activity, so I can draw activity B facing its own direction, activity B. Then for activity C, activity C is starting from the preceding activity of activity C is activity A. If you look at the example, you will see that activity A is preceding activity of activity C because activity A is under the preceding activity column, activity A is facing activity C. Then where will activity C end? Now, having looked at the preceding activity column, I can determine where activity C will start from. It will start from where A ended because activity C is facing activity as activity A as its preceding activity. But another question I would then ask myself is, where will activity C end? Where will activity C end? If I look at the column, at that same column, the preceding activity column, I can find activity C and D. I can find activity C and D together. Under the preceding activity column, I can find activity C and D together. What this means is that activity C and activity D, they are going to conclude their task. They are going to conclude their task into the same circle. They are going to conclude their task into the same circle. This is what this information is telling me. And then if I look at this information, I am about to draw activity C. I have not drawn activity D. I have not drawn activity D, so I cannot direct activity C to come and meet activity D because I have not drawn activity D. So I can draw activity C in any direction that I like, facing the end point. I haven't drawn activity C. The next activity for me to draw now is activity D. Then the question is, where will activity D start from? Activity D has activity B as its preceding activity. Activity D has activity B as its preceding activity. Then if I still look in that column, I still see activity C and D together, meaning that they end together. Now activity D will start from where activity B ended because it has activity B as its preceding activity. And then activity D will end where activity C ended because they end together. That's what I'm going to have. I have this is satisfied this that I have under the preceding activity, meaning that activity C and D end in the same event, end in the same circle. Then the next event for me to draw now is activity E. Then where will activity E start from? Activity E will start from where activity A ended. Activity E will start from where activity A ended. Where will activity E end? I can find activity E standing alone. So therefore, I draw activity E this way. Activity E that way. Then the next event for me to draw is activity F. Where will activity F start from? Activity F will start from where activity B ended, because activity B is the preceding activity of activity F. Activity B is the preceding activity of activity F. So activity F will start from where activity B ended. But where now will activity F end? I can find activity G and F together. I can find activity G and F together, meaning that activity G and F must end in the same place. But again, I have not drawn activity F. So I have not drawn activity G, so I can direct activity F in any direction towards the finish point. And then when I'm about to draw activity G, it has to come to where activity F is. So I can draw activity F in this direction. This is activity F. Having drawn activity F, the next activity for me to draw is activity G. Then what is the preceding activity of activity G? The preceding activity of activity G is activity C and D, meaning that activity G will commence from this circle where C and D end, because C and D is the preceding activity for activity G. But now that I've known the origin of activity G, then where is the conclusion of activity G? Activity G will conclude where F is, because G and F are supposed to conclude together. So activity G will originate from here and conclude here where F is. So this will be my activity G. Having drawn activity G, I can now move to activity H. Activity H has G and F as its preceding activity, meaning that activity H must originate from here, meaning that activity H must originate from here, meaning that activity H must originate from here. So if activity H originates from here, where is activity H going to end? I see activity H and I standing together, but I have not drawn activity I, so I can direct activity H towards the finish line. I can direct activity H towards the finish line. That will be activity H. Then activity I will commence from where activity E ended, because activity E is the preceding activity for activity I. This is where activity E ended. So activity I will commence from here, and then activity I will finish where H is, because activity I and H are standing together. So activity I will come in this direction. Activity I will come in that direction. Having done activity I, the next activity is activity J. Activity J will has H and I as its preceding activity, meaning that activity H must commence from here, and then activity J must commence from here, and then I see activity J standing alone. Activity J can come in this direction. Activity J can come in this direction. And then the last one, activity K, which will go into the final activity J. Having done this, I have completed the diagram. Having completed the diagram, I can now put the duration for activity A. We have 15 days, activity B is 12 days, activity C is 3 days, activity D is 5 days, activity E is 8 days, activity F is 12 days, activity G is 5 days, activity H is 14 days, activity I is 3 days, activity J is 14 days, and activity K is 10 days. Having put this duration, we can then go ahead to determine what is called the forward pass and backward pass. With this forward pass and backward pass, we'll be able to determine the duration of this project. Duration meaning how long it will take this project to be completed. How long, what is the duration, what is the maximum amount of weeks, what is the number of weeks that it will be completed. Having known the number of weeks each activity is supposed to be for, we now need to know the entire project, how long will it be completed. To do the forward pass, I divide each of these circles into two. I divide each of the circles into two. I divide each of the circles into two. I divide each of the circles into two. And when divided into each of the circles into two, the circle to my left, this circle to my left is what I will use for the forward pass. This circle to my left is what I will use for the forward pass. This circle to my left is what I will use for the forward pass. The question now is, how do I do the forward pass? I'm going to have to trace these arrows. I will follow this arrow from their origin to their destination. I will follow the arrows from their origin to their destination. Of course, minding when I get to the destination, how many arrows are arriving in the destination. For instance, if I follow arrow C from source to destination, when I get to the destination, I realize that arrow C is not the only one arriving in this destination. I also have arrow D arriving in the same destination. So that is going to affect whatever I'm going to do in both the forward pass and the backward pass. And then I will start here with zero. With zero, the commencement of the project is assumed to be zero. It is not only assumed to be zero, it is zero because time has not started yet. So by the time we start in zero, and meaning that activity A is commencing in week 0, activity A will take 15 weeks. If we start on week 0 and takes 15 weeks, by the time activity A is arriving here, 15 weeks has already passed. So I'm adding what I have here to what I have here. Then the same thing for activity B, will commence at week 0 and use 12 weeks. By the time activity B is arriving here, it's already 12 weeks. Now for activity C will take off in week 15 and use 3 weeks. If activity C takes off, commences in week 15 and uses 3 weeks, by the time activity C is arriving here, it is already 18 weeks. And like I said, I noticed that it is not only activity C that is arriving here. So for activity C, I have 15 plus 3, which is 18. Another activity is arriving here, which is activity D. Activity D itself is taking off on week 12 and to use 5 weeks, which means activity D will be arriving on week 17. So because these two arrows arrive here at the same time and one arrives on the 18, the other arrives on the 17, I'm going to be picking the highest of the two figures. So I'm going to be picking the highest of the two figures, which is 18. Then if I move from here, activity F will commence. Activity F will commence on the 12th. Activity F will commence on the 12th and use another 12 weeks. So by the time activity F is arriving here, it is 24 weeks. Again, I noticed that it's not only activity F that is arriving here. Activity G is also arriving here. Activity G will commence in 18 weeks and use 5 weeks and arrive on week 23rd. But since 24 is the highest of the two, I take 24. So by the time I arrive here, Activity E will take off in week 8. Activity E will take off in week 15 and use another 8 weeks. So it is only activity 8E that is arriving here. So I just add the 2 and have 23 here. So this one too has 2 arrows arriving here. The first one being activity H. Activity H will start in week 24 and use 14 weeks. So activity H will arrive in week 38, while activity I will start on week 23 and use 3 weeks. Activity I will arrive in week 26. So I take the highest of the two, which is 38. Only one arrow comes here, which is 38 plus 14, that's 50. That means the activity J will arrive here, we finish in week 52, while activity K will arrive here in week 62. So having done this simply indicates that the total duration of time that it will take to complete this project, the duration it will take to complete this project is going to be 62 weeks. That is what this implies, that it is going to take 62 weeks to complete this project. Of course, having done the forward pass, we can now look at what we call the backward pass. For the backward pass, just like I moved from here following the arrows, I'm going to move from here following the origin of the arrow back. When I was doing forward pass, I moved from my left to the right following the end of the arrow. But when I'm doing the backward pass, I'm moving from the end to the origin, following the origin of the arrow. So for this, I will have 62. And if I follow this arrow back, I have only one source originating. I have only one source originating from this circle, which is K. If I subtract 10 from this, I have 52. Then I follow this arrow back to, I have only one source originating from this circle. Then I subtract 14 from 52, that gives me 38. If I follow this arrow back here, I have only one arrow originating from here. I have only one arrow originating from here. So I subtract 14 from 38, I have 24. If I follow this arrow back here, I have only one arrow originating from this circle. So if I subtract 3 from 38, I have 35. If I follow this arrow into this circle, I have only one arrow originating from this circle, which is this. So if I subtract 5 from 24, I will have 19. If I follow this arrow back here, I can see that I have two arrows originating from this circle. I have 2 arrows originating from this circle. The first one is F. First one is F, which is now giving me 24. This 24 minus 12 minus 12, that gives me 12. The second one is D. The second one is D, which is now 19 minus 5, that gives me 14. I'm going to choose the lowest of the two this time because I'm subtracting. So I'll have 12 here. Again, if I follow this arrow into this circle, I see that I have 2 arrows originating from this circle. I have 2 arrows originating from that circle. The first one is arrow C, which is 3 weeks duration. So I have 19 minus 3, that's 16. And then the second one is arrow E, which is 8 weeks duration. So I have 35 minus 8, that's 27. Of course, again, I pick the lowest of the two. I have 16 here. If I follow this arrow to the back too, I see again that I have 2 arrows originating from this circle. The first one is arrow B, which will last for 12 weeks. So I have 12 minus 12, which is 0. And the second one is arrow A, which will last for 15 weeks. So I have 16 minus 15, which is 1. I pick the lowest of the two. So that concludes my backward pass. Having done the forward and the backward pass, I can now look at the different parts that are involved in this model. The different parts that are involved. I can have, this is a part, goes like this, comes here, comes like this, comes this way, and then here. So that's A, plus E plus I plus J, then plus K. That is one part. Another part can be this, then like this, then this, then this, and then this. I have A plus C plus G plus H plus J plus K. That's another part. Then another part is this, like this, comes here like this, goes here, comes here, and then to the end. I have the third part to be B plus D plus G plus H plus J plus K. And then this is another part here. This way, this way, this, and this. So we have part 4 to be B plus F plus H plus J plus K. These are the 4 parts that are involved in this model. If we now look at the time calculation of these 4 parts, I have here 15 plus 8 plus 3 plus 14 plus 10. And this one is 15 plus 3 plus 5 plus 14 plus 14 plus 10. And this is 12 plus 5 plus 5 again plus 14 plus 14 plus 10. And this is 12 plus 12 plus 14 plus 14, 12 plus 12 plus 14 plus 14 plus 10. So having done this, I realized that this gives me 50 weeks, this part 61 weeks, this part 60 weeks, and this part 62 weeks. So the part with the longest duration, which is equal to this, becomes the critical part. Critical part in the sense that each activity in that part are so critical to the completion of the task that any slack or any delay by any of this activity could cause a further delay in the completion of the task or the project.